Actually, let's start off with an exercise. Okay, so just for practice, start off with y equals 3x minus x squared. Okay. So this is a downward facing parabola, right? You see that you factor out an x, then you've got 3 minus x, right? So it intersects at 0 and 1, 2, 3, right? And it goes downwards. Okay. So you have a downwards facing parabola, and let's rotate that guy around the line x equals -1. Okay. So you take this area, and then you rotate it around the line x equals -1. 0, 1, 2, 3. And you get this sort of object. Okay. And I'd like you to set up an integral. So set up an integral to find the volume. Okay. So try to do that. Take a minute and see if you can do that. This one's a little bit tricky. Maybe it's trickier than the ones you've seen before. So, but maybe you can do it. Okay, talk to somebody nearby and see what you're doing, see what each other's doing. Sit up here. Okay, does anybody have some idea of how to do it? How do you do it? Or how just does anyone have just some beginning idea of what we need? What do we need to do? What do we need to do? Arclength, how about you? Yeah.
I think the alters minus plus y.
Yeah. So we need to, right, so we're gonna, right now we're using the method of washers, right? So we're gonna take this thing and then rotate it around, right? And we get this washer, right? We get this washer, right? So we have to figure out, what is, right? If we cut this at height y, right? So we're cutting the object at height y. We slice through it at height y, right? And we get this object here. Right? We get this object, and we have to. That's better. Right? We get this object here, and we have to figure out it's the big radius, and we have to figure out the little radius, right? So the big radius is going to be how do we figure out? Well, right, if this is y, then what's the x value? What are the x values there? Right. So here, right, we have this thing. Right. This is 0. This is 3. Right. This guy is y equals 3x minus x squared. Right. And we're going to cut the object at height y, right? So what are these points? Can anyone tell me what these points are? If this height is y, what is this point and what is this point? Okay, you want to tell me? What are the x values here, right? What are these points here? No? Gisela, how about you? What are these points? If the height is y, this is y equals 3x minus x squared. What are the x values here? You know how to do it. Does anyone know how to do it? Square root of 3x minus y? Well, yes, but then you're defining x in terms of x, right? If you say x is going to be the square root of 3x minus y, then you're saying, you can't use x. You're defining x in terms of, it's also depending on x, right? So you don't want to do it that way. But right? Just if this is true, then how do you solve for x? Well, x squared minus 3x plus y is equal to 0, right? And then you use a quadratic equation, right? So x is going to be 3 plus or minus the square root of 9 minus 4y over 2. Right? It's the quadratic equation, right? So this thing here and this thing here, we get 3 halves plus root 9 fourths y, 9 minus 4y over 2, and we get 3 halves minus root 9 minus 4y over 2. Right? Those are the x coordinates there. Right? So from x equals minus 1 to here, right, what's the big radius? Big radius at height y is what? Well, it's going to be what is it? Somebody say it, please. Yeah? Plus 1, right? It's just this plus 1. Right? 3/2 plus this plus 1, right? And then the small radius is going to be this left guy plus 1, right? This plus 1, right? Okay. So, right. So, what's the integral? Well, we're going to integrate we're going to integrate against y, right, from 0 to the height, right? The height is going to occur at 3/2. It turns out to be 9/4. Okay, so we integrate from 0 to 9/4. Pi outer guy squared minus inside radius squared. dy. Okay, so just plug in, right? Just plug in these things. Right. You have pi times this thing squared minus this thing squared, quantity dy. Okay. And I'll write it down. Integral from 0 to 9/4 of pi times 3/2 plus the square root of 9 minus 4y over 2 plus 1 quantity squared minus 3/2 minus root 9 minus 4y over 2 plus 1 quantity squared. Okay, everyone all right with that? Any questions on? Any questions? No? Okay, so that's that's the method of washers, right? You take these horizontal slices, right, and then you rotate those, right? So your object looks like this, say, and you do a horizontal cut here, and you rotate that thing around, and you get this, solid, right? You get this this thing with a hole in it, okay? Right? And then you integrate the volumes, you sum the volumes of those guys, and then you get the total volume. Okay. Okay. There's a different way to do it, which is instead of cutting like this, we're going to cut like this. Okay. We'll cut vertically. Okay. And this is called the method of shells. And when they say shells, they really mean cylindrical shells. Okay, and this is, it's not all that different. So let's do the same problem, right? Y equals 3x minus x squared, right? 0, 3. Here's the y-axis. Here is, oops, it's not the y-axis. Here's the y-axis, here's the line, x equals -1, and we rotate that guy around, and we get this object. Okay. again, we get this object. But this time we're going to express the area like this. We're going to express the volume like this. We're going to take vertical pieces, vertical rectangles. Rectangles that are, so take rectangles that are parallel to the axis of rotation. Axis of rotation. Okay, in the last time, right, here's our axis of rotation, and we're taking rectangles that are perpendicular, right? We're taking rectangles that were perpendicular to it. This time we're going to be taking guys that are parallel, right? And then when we rotate these things around, what we get is these cylinders. Okay, right? We get these cylinders, and the volume of each cylinder is going to be 2 pi times r, 2 pi times r, right? 2 pi times the radius, so let's call this thing r, right? 2 pi times r times the height times a small thickness, right? So we have, here's the picture, right? You have a height at time x, right? You have a radius at time x, right? And you have this tiny thickness dx. Okay, and then you rotate that thing around, right? You rotate that thing around, and you get this cylinder. Okay, and the volume of the cylinder is, right, the circumference, right, 2 pi r, circumference times height times thickness. So volume of the cylinder, volume of the cylindrical shell is going to be the circumference not sure what's happening. every pen I take starts doing that. Okay, so circumference times height times thickness, and that will give you the volume of the shell, and then you sum up all the shells. Okay, so right, so so in this picture here, let's do it here. X, right? If this is x, right, what's the height? If this is x, what's the height? What's the height? You know, I just wrote it, right? 3x minus x squared, right? So the height is going to be 3x minus x squared. So height is 3x minus x squared. What's the radius of the cylinder? Somebody said it? X plus 1, right? The radius is going to be x plus 1. Right? And that's it, right? We just need, so the volume then is going to be the sum from, as x ranges from 0 to 3, of 2 pi r, right? 2 pi r times the height times dx. Right? 2 pi r times the height times the thickness, right? And that'll give us the volume. That'll give us the volume of the shell, right? That will give us the volume of this one shell here. And then we're going to sum over all shells between here and here, and that will give us the volume of the whole thing. Okay. So just like in the previous one, right? In the previous one, what we did was slice like this, right? And we ended up getting these washers. Okay. We ended up getting these washers. Really, what we were doing was taking the initial object and then breaking it up into rectangles, into horizontal rectangles, right? And then we looked at the washer that we generated by spinning that horizontal rectangle around, and then we added up all the volumes of the washers. Okay. We're going to do pretty much the same thing over here. We take now we take vertical rectangles, we spin those guys around, and we get this cylinder, right? And then we sum over all, we add up over all. We take all those vertical rectangles and sum them together. Spin them and sum them together, and then we get the volume. Okay, so that's the idea, right? With washers, you do horizontal. I mean, you cut these things perpendicular. You make rectangles that are perpendicular to the axis, and with the shells, you do things that are parallel to the axis. Okay, so that's the only difference. It's not that. Okay, so let's see. Let me see if you can do one. Let me see if you can set one up. Okay, so y equals x squared, and y equals 2x. Okay, and let's say that you take this thing and you rotate it around the around the y-axis. Okay, I'd like you to set up the integral in the shell sense. Okay, set up an integral for the volume using the method of shells. Okay, using the method. Okay, so take 1 minute and see if you can do it. Okay, turn to somebody nearby and talk, please. Can you talk with me, Xiao, about it? Please speak louder. Yeah. Oh yeah, sure. Is that better? Or? No? You still cannot see?
It's still like too dark on the corner.
It's too dark on the corner. Oh, I see. How about move to the middle? Can you move to the middle? I think that'll be easy.
Okay.
No? You see, if it's like this, now it's really dark in here.
Okay.
Yeah. If you want, I think it's better to move to the middle. Move to the middle, please.
I think I can see it.
I don't think so. Why don't you want to move to the middle?
I just use it to see you.
I see. Well, can you slide your table over?
It's okay. I just cannot see the other part of it, but for the most part I can see it. So I just like if I try really hard to see it, it work.
Okay. 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 Can you read this?
Mm-hmm.
Okay. Okay. Who would like to do it? I choose somebody. Li Xiao, how about you? How do you do it?
Integral to O to 2.
So the integral from 0 to 2. Right. So yeah. So you figured out that these guys intersect at 2. Right.
Yeah, 2 pi times x times 2x subject x squared.
Perfect. Okay, everyone get that? Xu Chengcheng, you don't look like you got it.
No, I didn't.
You didn't get it. What did you get?
I got integral from 0 to 2
Mm-hmm.
pi 2x minus x squared of dx.
Dx. Okay. So what that would be is so this you're thinking of some sort of pi r squared thing, right? Pi r squared thing. So that is basically you have some object. Let's see, it's like 0, 2. You have some object like this, and you're rotating that. That would be like an object when sliced. The radius is 2x minus x squared. Okay. When you slice it, the radius is 2x minus x squared. Okay. Now this object, the thing that we're doing here, is not like that, right? Right. So I think you're still thinking about the method of washers and disks, right? So remember this is not the method of washers and disks. Okay. So what you have to do is this: you say, okay, I'm going to take my initial area, and then I'm going to create rectangles that are parallel to the axis of rotation. Okay, so here it is, right? What's the height of that rectangle? Well, the height is going to be 2x minus x squared, right? That's the height, right? Because this, right? If this is x, say, right? As x ranges from 0 to 2, the height of this rectangle is going to be 2x minus x squared. Right? You see that? Okay. And then you take that thing and you rotate it around. You rotate it around. Okay. Okay. And you get this cylinder, right? So it's not you get this sort of thing, right? You see, you get a cylinder. You know, it's hollow on the inside. Okay, it's hollow on the inside. It's not, you know, it's not a solid. It's not a solid cylinder. It's just the shell of a cylinder. Okay, it's just the shell of a cylinder. It's, you know, it's basically a cylinder with a cylinder removed from the inside. Okay, and the thickness here is dx, right? The thickness at the top here is dx, and the radius here is x. Okay, and the height is 2x minus x squared. Okay, so the volume of this shell, is going to be 2 pi x, right? 2 pi times the radius times the height times dx. Does that one make sense to you?
Yeah.
Yeah. Okay. Right. You take the circumference, right? Circumference times the height times the thickness, right? And that'll give you the volume of the shell. Okay. So that's what the shell did, right? You got from 0 to 2 pi x, 2x minus x squared dx. Okay. Okay. Just for practice, can anyone read off immediately what the method of washes would give us? What would we get by method of washes? The integral from 0 to 4. Now we're going to have some pi r squareds involved, right? What's it going to be? Can anyone just read it off immediately? Maybe it's not so easy. Can anyone read it off? So, right, so you're going to get, if you slice at a height y, right, you get this thing, right? What's the x value here? The x value is going to be y over 2. Right? The x value here is going to be the square root of 1. Right? So you're going to get pi bigger die squared minus smaller inside die squared dx, dy. Okay? Okay, let me have you do another one. So here it is. F of x is the square root of 3 times x when x is between 0 and 1. And it's going to be square root of 4 minus x squared when 1 is between x and 2. Okay. So the picture is like this. 1, 2. From here to here, 1, 2. From here to here, it looks like a circle, right? But from here to here, looks like when x is 1. Wait a second. 4 minus x squared, 4, 3, yeah, okay. So yeah, so it's going to intersect, the point of